Dear fellow coders, welcome to One Little Coder. In this Python Applied NLP tutorial, we are going to look at a new Spacy extension called Numerizer. Numerizer is a Spacy extension or also a standalone Python library that will help you convert natural language numerics into integers and floats. For example, if you say 935, it's going to give you 935 in numbers. And this is a library called Numerizer. It has been developed by Jaydev Deshpande. So thanks to Jaydev who made this library and made it open source. This is originally a port from a Ruby library of the same name. So you can install this library with typical Python libraries pip and you can get started. As part of this tutorial, I'm not just going to show you how to use this library, but we are also going to build a web application using Streamlit that looks like this. So we're going to have a web application where we can enter a text and that text will give us the equivalent numeric output. You can have the numeric output as a JSON file separately or like a dictionary, or you can also replace it in your input text, whichever you find it more comfortable or more applicable to your workflow. And at the end of this video, we are going to deploy this web application on Hugging Face Spaces for free as part of your portfolio. Let's say you're looking for a job, you want to expand your data science portfolio, you can deploy this. If this is something that interests you, please hit the like button and subscribe to the channel, and let's get started. First of all, Spacy is a wonderful library. I think everyone in the NLP world loves Spacy. And the good thing with Spacy is not something that works only alone, but it also works very well with other libraries. Take Numerizer for example. There is a way for you to use Numerizer standalone. Just install Numerizer, pip install Numerizer, and then from Numerizer import Numerize, and then you can start play with this. Like you can give 42 and then you get 42, you get 9 and 3/4, you get 9.75. You can do all these things. But the very good thing due to Spacy's ecosystem is that now Numerizer is also available as a Spacy extension. What does it mean? It means you just basically you can basically use Numerizer as part of your Spacy workflow. So let us say that you've got a very huge document which you're going to parse with Spacy, and you want to say, I want to be very specific about this document because I have a lot of numbers in this document, especially let's say financial numbers and some other numbers. And you are interested in getting those numbers into actual numbers so that you can do some math, calculation, data science, make chart, like whatnot. If that is your objective, then you have to use Numerizer, or it is better if you use Numerizer as part of your Spacy workflow. And the code is quite simple. You just import Spacy, load the language model, load the pipeline, trained pipeline, Spacy pipeline that is available for you, in this case English. Then give the text and create a doc object, which is the first step in any Spacy project that you would do. And then use Numerizer. That's it. Numerize. And then you have the result in place. And I'm going to just show you how to convert this into a web application as well. Let me just repeat it. The workflow. You have to install Numerizer, install Spacy if you do not have, and load Numerizer, load the libraries, load the language model, load the create a doc object from the text, and apply Numerize, and then you have it. And the good thing because you can use it with Spacy is it's not just you can do it in the whole text. Let's say now you decided that you want to take this number Numerize only when it comes to money. Let's say there is an entity recognition that's happening in Spacy, and then you want to do this only for numbers that are related to money, not for any number. You can just simply say doc Numerize, and then you can add an argument saying labels is equal to money. So what are the entity types that you give here in the labels? Your Numerize function is going to get applied to only those entities. That is again a great advantage of using Numerize library with Spacy. And then you have like other advantages like how you can use it as token and like all the other things that you have. Like you can do a lot of the things, but the good thing is there is a Spacy extension, and that's what we are going to explore today thanks to Jaydev. So now you know about Numerizer. Now you know about the Spacy extension. Now without wasting time, what I'm going to do is I'm going to show you how to build this web application. So for building this web application, I'm going to use Visual Studio Code. When I use Visual Studio Code, I would usually like to keep my Visual Studio Code only for that particular folder. And if you're not familiar with that, it's very simple. I have to do like this item, and then I go inside the folder where I have, let's say, let me clear it. And from that folder, I'm going to say code dot. I'm inside the folder, I'm going to say code dot, and then my Visual Studio Code VS Code opens with the current folder. So I've got app.py file, I've got requirements.txt file. Requirements.txt file lists all the libraries, Python libraries that we need. We are going to use Streamlit for web application. We're going to use Spacy. We're going to use Numerizer. So we have 3 libraries. I'm not specifying the version of the library, but if you want, you can do that as well. The next thing is, for our Streamlit library, we need an app.py file that's going to be the backbone of our Streamlit web application. If you are wondering what is that we are going to build, you can quickly see the application. So we are going to have a very simple application that has a text box, and then it's going to parse the text and then give you the output. Okay, so the first step after we create app.py file is to load the required libraries. Streamlit as st, import Spacy, and Spacy requires, like, for us to do NLP, English NLP on Spacy, we can download the pre-trained Spacy pipelines. There are multiple ways to do this thing, and the easiest way, at least I have selected here, is import this as a library itself. So if you want to do this, if you want to do it in the way that I'm doing it, all you have to do is pip3 install ncore websm. So that will install this language pipeline as a Python library, which means you can use it as your dependency as well. So that's it. So there are different ways you could be doing it a different way, but if you prefer this way, this is easier because this helps us manage the dependencies as well. Then from Numerizer, import Numerizer. So we have imported the required libraries. The next thing I'm going to show you is the backend. The first thing is we need an input text. So let me close this. So we need an input text. So I'm not coming into the Streamlit part. Let's assume that you have a hard-coded text. The next thing is you need to load the model, and you're loading the model with ncore websm. I'm going to get into it. After you load the model, you have to create a doc object, and the doc object gets saved in the doc object. And after you have the doc object, you are going to numerize it. Once you numerize it, what you get as an output is the numerized objects like this, like a dictionary or a JSON. So you're going to have the text and the equivalent number in quotes, like string, which you can, typecast. So that's the output of this. The rest of the section of this code tries to find that in this input text and replace it. Okay. So now this is the backend. This is basically what we are doing. Let me explain you the front end. So the front end is quite simple. You need a title, and you're going to say st.title, and then you give the title. It takes markdown syntax, which means I can put the star here, and it can help us, do italics. I can do bold. I can do whatever. I do it in markdown. So after we have the title, the next thing is we need to have the input text. So we have a markdown text that says input text. Then we have a text input, the box that you just saw, and it needs a label that says, what do you want to do with the box, and also a default value in case, people don't know what to enter. And after you do that, now we need to say something like, what is the output of it. So I'm just printing the same input as an output for the user to just see. We can disable it if we don't want. The next thing is we have already done numerization, and then after we do numerization, we are just displaying the dictionary. We have a markdown that says numerize section, and then we have a markdown that actually displays the numerized parts as a JSON object like this, or dictionary. And then finally we are taking the input text, and then we are going to find the numerized, like wherever you see 2, we are going to replace it with the number 2. So for that, we are going to take the text, which is the input text. Okay, we have taken the input text, created a new temporary object, and then we are going to iterate through the dictionary. In this case, it's going to go over 2, 2, 4. Okay, we're going to go over the keys, and then we are going to say string replace in this text. Wherever you see this key, replace it with this value. So wherever you see 2, replace it with this. Wherever you see 2, replace it with this. Wherever you see 4, replace it with this. And then we do it in an iterative fashion. Like you can again do this in a lot of different ways. You can use regex, you can use join, you can try a lot of different things. But to keep it simple, we have done this. And then finally, we are going to say output text. And then we are going to write the formatted or replaced output sentence, that is numerized, which has numbers in it, not just words. So basically, we have taken the user input in the text box and shown the numerized text in the output. Even though you may not do this in your real life, where you might use this number to make a chart or whatnot, I'm just showing you as a simple application where you can input your text and then get an output text that is numerized. We can even call it numerized output text. I think that is numerized output text. That makes more sense. Okay, so now we have defined all these individual sections. There is a very important section that we need to address, which is how do we deal with downloading a Spacy model and how do we process or create a doc object. Because this is a task that might happen multiple times, I decided to use Streamlit cache functionality. So it is a decorator. You have to use Streamlit cache, and then we have to allow output mutation because we are going to process this and get new output, and then we don't want to show any warnings, so we're suppressing warnings. So we have defined a function just to load the model. So we have this ncore WebSM as a Python library that has been imported here, and from that we are loading the model, and just that model object is returned. You can either do like this, or you can say okay, model is equal to do something like this and then return the model, whichever you are comfortable, like more readable. Explicit is better than implicit, whichever you find it better, you can do that. After you return the model, the next thing is creating a doc object, and I'm going to do the same thing there. The only difference is here there is no argument to this function because I know I'm dealing only with English model, but here the text could be anything. So we are defining the text, input text, and then we are saying load the model, which is this function, and we are assigning it to the NLP object, and then we are creating a doc object with NLP of text, the text that has been given. And when we call this function process text, you can see we are calling it with the input text that comes to us through the text input. So the text box takes the input and gives the input to us, and that input is sent to this function, and this function starts by loading the model, and after it loads the model, it creates the doc object. Then the doc object is assigned to the doc object, and then we are numerizing on top of the doc object. I hope this is clear, the architecture of this code. It's a very simple monolithic code, nothing crazy, nothing great. Let me run this. The way I'm going to run this is any Streamlit application. First, if you do not know how to install any of these libraries, pip3 install, just put the library names and install it. Okay, so the way we are going to run this application is we're going to say Streamlit run app.py. Once we do this, we get the URL and then we can double click it. You can see that it is active. You have multiple options here. You can go to the settings and say use light theme. You can go to the settings and say dark theme, and you have like a lot of different options there for you to use as a end user, not just as a developer. So now we have got this text, so let me just go ahead and then give something interesting. Maybe I can copy something from the example and then I can just paste it here for now, and then press enter for it to run. It's based on reactive programming paradigm, which means the moment I press something, it is going to run. So you can see 9 3/4 has been translated into 9.5, and then you have platform 9.5. So maybe we can try one more thing, like which is 9 975. Let me try my luck. We have 975. So I can get one more example from here and then say something that looks like this. And then you have Hogwarts Expresses at platform 9.75. Currently, if you see our code, we are translating everything that we have. If we want to specifically do only for money, then we can probably say label equal to money, and then we can go back, rerun our file, and then say, currently see it didn't do anything because 9.75 is not money. So we can change the text to say maybe something like this: I earned dollars, then try. Okay, it doesn't. Okay, I don't know how to give money. Maybe let's take the example from here. We can say $200 million, right? So maybe that will be captured as money, and yeah, over $200 million is captured as money. So if you want to do only money or any other entity, you can specify it here, but for our use case that is not required. Maybe if you want to enhance this application, you can have like a checkbox and then say which is the entity that you want to capture, and then based on that you can show, but in our case that is not required. So at this point we have our web application, Streamlit web application, which is Numerizer, powered by Spacy, Numerizer and Streamlit, running so well and fine on our local machine. What do we do next? Like at the start of the video, I promised you that we are going to deploy this on Hugging Face Spaces. So that's what we're going to do next. I'm going to go to my new tab and I'm going to say Hugging Face Spaces. And it's going to take me to the Hugging Face website where I have to enter my password correctly. Hopefully go log in and try my luck. Did I enter? Okay, great. I entered it correctly. So this is my dashboard of Hugging Face Spaces. I'm going to go click Spaces and then say I want to create a new space. And this is again like a lot of different ways to do this thing. You can even get it. You can even get it. But yeah, because I don't want to, get into terminal and git. I'm just going to say do everything through the browser. Numerizerlit. Should I say Numerizerlit? Numerizerlit. Okay, it's a Streamlit application. It's a public repository. Anybody can see it, and I'm going to create it. So as you can see, you can git clone this on your local machine, commit, add, commit, push, and then come back and see here. But on the other hand, you can create this on your browser as well, or you can even upload files. So to make it simple, I'm going to just copy this entire thing, paste it here, and then create save, and it's going to throw an error. Of course, I would tell you why it's going to throw an error. You might have already guessed it. It would throw an error because we don't. Oh, did it just start running? It's not possible. Let's see. My assumption is it would ideally throw an error because we have not defined the dependencies correctly. So we need one more file that would tell us, create a new file, requirements.txt, and go back to our requirements.txt, come back here, create new file. Because we have not defined the dependencies, the Hugging Face Spaces engine wouldn't know what all the libraries that we need. So whatever libraries that you use in your code, you need to use it, and there is a build error. So let's look at the build error. What is the build error that we are seeing? There is no matching distribution for Encore WebSM. So let's try to remove that from our dependency and then see. The dependency that we mentioned as Encore WebSM is not directly available from PyPy for Hugging Face Spaces to install. So we have found a workaround. I had underestimated this. My apologies for that, to take you through my failure and then show you. So what we have done right now is we have found out the repository where Spacy pipelines are released, and you can directly go there and download it and then upload it separately if you want, or you can do pip install on this tar file. So what I have done here is I've just copied this path. I've gone to our Hugging Face requirements.txt, edited it, and then mentioned that path, like whatever I just copied, I pasted it and then click commit changes. Once I did that, then it started building it again. And in the code, the change that I've done from what I showed you is I disabled import encore web SM, and I'm downloading it directly from spacy.load. So these are the changes that I've done, and my apologies again that I had explained something on my local machine, but when we had to deploy, we had faced this issue, so we had to tweak a little bit. Now after this, we are completely fine, up and running. We have our numerizer ready. So now I can go here and then probably give the same text that Jaydev has given in the example. Copy this, come to our numerizer. Okay, let me close this and then paste it, and then click enter, and then we have our output as a JSON object, and we have our output text that has been replaced. So we have our title, input text, numerize section, output text, and then we have it ready. So we started from understanding Numerizer library. We went through how to use Numerizer library. So we understood how to use Numerizer library as a Spacy extension, and then we finally built a Streamlit application on a local machine, which worked completely fine until we decided to deploy it on Hugging Face Spaces, where we realized that one of our dependency had issue. Then we had to tweak the code a little bit to download the model directly from the GitHub release, and also to use spacy.load in the code instead of importing the pipeline, Spacy pipeline, model pipeline as a Python library. But we have completely learned the entire process of building an applied NLP web application that is powered by Spacy and Numerizer, where you can just give input text and then it will translate the numbers in the text into integers and floats, which you can use for anything, whatever you want. Data visualization, to do natural language processing, or to create like a chatbot, natural language understanding, do calculations, whatnot. Everything you could do with this web application, and then it is deployed on Hugging Face Spaces for completely free. If you like this tutorial, please let me know in the comment section. I would love to know your feedback. Otherwise, happy coding.